Welcome back to the Dargslan Linux series. This is part 4 of 24, and today we're sitting down with permissions and ownership. The quiet model that decides who can do what on every Linux machine in the world. It's not glamorous, but once it clicks, a lot of Linux suddenly makes sense. So let's take it slow and walk through it together. Here's the path we'll take. We'll start with the 3x3 model, 3 groups, 3 permissions. Then learn to read that cryptic LSL output without squinting. From there, chmod in both its symbolic and numeric forms, chown for ownership, and a careful look at sudo and root. We'll close with the special permissions, decoded, setgid, and the sticky bit, so you recognize them in the wild. Before we touch a single command, it's worth asking why permissions exist at all. Linux was designed from the start for many people sharing one machine, so every file carries rules about who can read it, change it, or run it. But even on your own laptop, those rules earn their keep. They stop a buggy program from trashing system files, and they keep services like web servers boxed in so one exploit doesn't hand over the whole machine. So here's the entire model on one screen. Linux looks at 3 groups: the user who owns the file, the group assigned to it, and everyone else. And for each group, it answers 3 questions. Can you read it? Can you write to it? Can you execute it? That's 9 yes or no bits per file. Every permission rule you'll ever meet in Linux is just some arrangement of these 9 switches. Now let's see those 9 switches in the wild. When you run LSL, that first cluster of characters tells the whole story. The leading dash means it's a regular file. Then drwx for the owner Laszlo. Full control, read, write, execute, followed by rx for the devs group who can read and run but not modify, and finally r for everyone else, who only get to look. After that come the owner, the group, the size, the date, and the file name. One dense little line, but every character earns its place. Here's the twist that trips up almost everyone. Those same 3 letters, R, W, X, mean something different when they apply to a directory. On a file, they're about contents. Read it, change it, run it. On a folder, they're about the folder itself. R lets you list what's inside, W lets you add or remove entries, and X lets you actually step into it with CD. So a folder you can list but not enter? That's a real thing. And now you know why. Now that we understand what permissions mean, let's actually change them. The friendliest way is the symbolic form. You pick a who, an operator, and a permission. So u+x-script.sh adds execute for the owner. Go wnotes.md strips right from group and others. And arrfile.txt sets everyone to exactly read-only. Nothing more, nothing less. Read it left to right, and it almost speaks English. Once symbolic mode clicks, you'll often see folks reach for the numeric shortcut instead. The trick is simple addition. Read is 4, write is 2, execute is 1. Add them up per group, and drwx becomes 7. So 755 means the owner gets full access, while group and others can read and execute but not write. A few patterns are worth memorizing. 755 for scripts and executables, 644 for regular files, and 700 when something should stay strictly private to you. Now, permissions tell us what can be done to a file, but chown answers a different question. By whom? The syntax mirrors how we think about it. User, group, then the file. You can change just the owner, just the group by leading with a colon or both at once. Add -r and it sweeps through an entire directory tree, which is how you'd hand over something like var www to the web server's account. One catch worth remembering. Chown almost always needs sudo because only root can give a file away to someone else. And speaking of needing sudo, let's talk about what that word actually means. Root is Linux's all-powerful user, UID 0, capable of touching every file on the system. As a regular user, you're sandboxed to your home directory, which is genuinely a good thing. It means a typo can't wipe out. etc. Sudo is the bridge. It lets you borrow root's powers for a single command. The habit to build is simple. Don't reach for sudo by default. Try the command first, and only escalate when Linux tells you permission was denied. In practice, sudo shows up in a handful of patterns worth recognizing. Sticking sudo in front of a single command, like apt update, is the everyday form. And the safest. Sudo-i drops you into a full root shell, which is powerful but risky, because now every command runs as root. Sudo bang bang is a lovely shortcut for when you forgot sudo the first time. You can also borrow another user's identity with -u, or use sudo to read protected files like shadow. And one detail that trips people up. Sudo asks for your password, not roots. After that, it's cached for about 15 minutes, so you won't be retyping it constantly. Let's ground all this theory in a few situations you'll actually hit. You wrote a script and bash refuses to run it? It's almost always a missing execute bit. Chmod plus X fixes it. Sharing a folder with your team means setting group ownership to devs and using 770, so the group has full access while everyone else is locked out. For a private notes folder, 700 keeps it strictly yours. And for a web server, you hand ownership to www data and apply 755 recursively, so Apache can read what it needs to serve. Same building blocks every time, just arranged for the job. Now, beyond the standard read, write, and execute, Linux has 3 special bits worth knowing. Settoid lets a program run with its owner's privileges. That's how passwd, owned by root, can quietly update etc. shadow when you change your password. Setgid on a directory means new files automatically inherit the folder's group, which is gold for team workspaces. And the sticky bit, that little T on a TMP, lets everyone write there but ensures only you can delete your own files. You'll spot these in the wild. Now you'll know what they're doing. Now before we move on, let's talk about 3 mistakes that bite almost every beginner. First, chmod 777 on anything. That's not fixing permissions, that's removing them. Stick with 644 for files and 755 for directories. Second, reaching for sudo on every command. One typo with rm and you've got a very bad afternoon. And third, chown, R on the root directory. That one sentence can brick a working system in seconds. Always scope your changes to a specific path you actually own. So when you do hit that dreaded permission-denied message, here's a 4-step diagnostic that handles almost every case. Start with who you are. Whoami and groups confirm your identity. Then LSL on the file itself to see who owns it and what's allowed. If that looks fine, check the path with nameil, because you need execute permission on every directory leading to the file. Once you know what's wrong, the fix picks itself. chmod for permissions, chown for ownership, sudo only when you genuinely need root. Let's pull the threads together. The whole permission model comes down to 3 groups and 3 actions. 9 bits, nothing more. Remember that on directories, those letters shift meaning. Read lists, write modifies contents, execute lets you enter. The numbers are just addition, chmod, and chown answer different questions, and sudo is a tool you reach for deliberately, not a habit. Get comfortable with these 5 ideas and the rest is just practice. And that brings us to the end of part 4. Next up, we step into users and groups, the layer underneath everything we just covered. Because before Linux can decide what you're allowed to do, it has to know who you are, and that answer lives in 2 small files, etc. password and etc. shadow. Take a breath, stretch, and I'll see you in part 5.